Ever wonder why you can't remember things?
Ever wonder how memory works?
Are you a monkey?
This is an example of the phonological Thor. Confused? Well, we're here to explain. We have all the answers. Behold, the working memory model.
You'll be able to figure out where you went wrong. You'll realize why definitions slip from your mind, why multitasking can be so distracting.
You'll understand your memory.
It's easy! The working memory model explains exactly how our short-term memory works. It's perfect for psychologists or anyone who wants to understand their memory. The model divides up our short-term memory into 3 distinct parts: the central executive, the visuospatial sketchpad, and the phonological loop. Feel like those words are a bit overwhelming? Well, don't worry. It's easier than it sounds.
Let's start with the central executive. The central executive is like the chief, in charge of our short-term memory. This is the place where our short-term thoughts and things we sense are processed. This processing of information is referred to as cognition. The central executive uses that processed information for a variety of things, to make plans or solve problems. Ha! Let me give you an example. Let's say you're feeling a little hungry. Well, that information is processed by your central executive. After processing that information, you decide to go get something to eat so you don't feel hungry anymore. The reason you decided to go eat is because your central executive processed the information and said that you were hungry. And then it made the decision to go get something to eat. Good decision. Get it? Easy, right? I told you the working memory model was great.
Now, let's move on to the visuospatial sketchpad. I said before that the central executive was the chief, right? Well, the visuospatial sketchpad is one of the chief's workers. We call it a slave system. The visuospatial sketchpad helps the central executive process visual and spatial information. Basically, it's our inner eye, helping us process information about the physical world around us. Whenever we determine what color something is, how far away something is, or even what's around the corner, we are using our visuospatial sketchpad. You got that? Good. Now let's discuss the phonological loop.
This is the other slave system. It deals with auditory information, or what we hear. The loop is made up of 2 parts: the phonological store and the articulatory control process. The phonological store is what we use to store information that we hear. That stupid Justin Bieber song that you heard a few hours ago, playing over and over in your head, it's there because your phonological store is holding on to it. The articulatory control process has to do with production of speech. Whenever you say something, your articulatory control process is what helps you produce those words. The articulatory control process doesn't just produce words that you say out loud.
Remember that Justin Bieber song? Chances are, when it plays in your head, you sometimes hear your own voice singing it. That is your inner voice, a result of the articulatory control process. When you read something and hear the voice in your head, that's your articulatory control process producing mental speech. Now, how do the articulatory control process and phonological store work together, you ask? That's simple. Let's go back to that Justin Bieber song. When you first heard the song, you use your phonological store to encode the memory of the song into your mind. Then, when you hear your own voice singing the song in your head, that's your articulatory control process creating mental speech. Because you can hear the voice in your head, your phonological store again encodes the memory, creating a loop. That is how the phonological loop works.
As you can see, the working memory model is super comprehensive. It tells you everything you need to know about the short-term memory. I know what you're thinking. How can I be so sure that you aren't making this all up?
2 studies have been conducted that will clear away any of your doubts. The first, by Robinson, Anderson, Barker, Bradley, Henson, and Fernier, and the second by Warrington and Chalice. The first study, conducted in 1996, examined how involving different components of the working memory influenced the selection of chess moves by both strong and weak players. Here are the results. The graph shows that tasks involving the phonological loop do not affect the quality of the chess moves selected. However, tasks involving the visuospatial sketchpad and the central executive significantly reduce the quality of the chess moves selected. Chess requires players to look at the board and imagine how the pieces fit together. This involves the visuospatial sketchpad. It also involves critical thinking and decision-making. This involves the central executive. These findings prove that there are different components to our short-term memory. If two tasks involve two different components of our memory, then these two tasks will not interrupt each other. However, if two tasks both involve the same component, both processes will be interfered with. Isn't that amazing?
Now for the second study, conducted in 1972. Warrington and Salas thus studied KF, a man involved in a motorcycle accident. The motorcycle accident irreversibly damaged KF's memory. While his long-term memory was fairly intact, he now had trouble with his short-term memory. However, not all of KF's short-term memories were lost. He could remember sounds like a telephone ringing, but had problems with numbers, letters, digits, and other verbal information. This proves that the short-term memory is made up of multiple components. Parts of KF's short-term memory functioned while others did not. Specifically, within KF's phonological loop, the phonological store seemed to function properly, but his articulatory control process did not. This clearly proves that the short-term memory has multiple components. It also disproves the vastly inferior multi-store memory model. The multi-store memory model is far too simplistic. It also suggests that there is only one component to do with short-term memory.
So there you go. Everyone knows the working memory model works. That's why it has the word working in it. However, that's not the only reason why it has the word working in it. The working memory model also has amazing practical applications. Psychologists can use it to improve and expand their studies on memory. It opens up a whole new world of possibilities and experiments to do with short-term memory. We can study specific aspects and components of short-term memory instead of having generalized, simplistic studies. It not only improves psychologists' understanding, it also improves yours.
I said before that we tell you why definitions slip from your mind and why multitasking can be so distracting. So here it is. We told you that involving the same component in two tasks can interfere with both, right? So if you're using the phonological loop to memorize definitions, you can't talk with other people or listen to loud music.
So there you go. The working memory model can even help you work and study.
It's the bomb!
So, do you understand the working memory model?
You understand that the working memory model is the best memory model? Excellent.
If you want to learn more about this amazing model, call 555 Working Memory Model. And remember, the working memory model is the bomb!